Contact anticipation is essential for collision avoidance, intentional interaction, and contact-rich manipulation for humans. Our primary focus in this work is how can robots similarly utilize contact anticipation. Artificial skin has been used to sense proximity, and 3D printed skins are low cost and scalable, but a unified 3D printed proximity and tactile sensing platform is unexplored. In this work, we present a 3D printed whole body proximity and tactile sensing artificial skin, as well as a method for mapping its sensing space. Our artificial skins are procedurally generated to fit a specific robot's morphology. Conductive discs are then distributed internally to maximize sensing coverage. Finally, non-overlapping wires are generated in between the sensing discs and exposed connection ports to make individually addressable capacitive sensors. Capacitive sensors can detect both proximity and touch and are non-linearly sensitive to nearby objects based on their physical properties. The digital model of each skin unit is 3D printed using conductive and non-conductive filaments to make functional capacitive sensors when powered by a microcontroller. We then collected 17 hover and contact trajectories to characterize each sensor and validate our approach. The collected trajectories were also used to train a machine learning model that predicts object proximity. An ensemble of MLPs were used to predict object proximity because it also returns a prediction uncertainty in addition to the predicted position. After sampling capacitance readings, we filter our predictions by their uncertainty to map out the proximal receptive field, that is, a body-centric zone of nearby space that each sensor can sense in. A parallel plate assumption was also tested with our artificial skins to convert raw capacitance measurements to a point cloud. This method supports both single and multi-touch capabilities. The artificial skins were generated around the robot's specific shape, allowing them to have a snap-on fit and preserve their kinematic chain. Finally, we used our GenTact-Prox skins to anticipate contact and be collision compliant. The robot was tasked to trace circles while also being repelled from detected obstacles. Once the obstructions were cleared, it resumed nominal operation. Thank you for watching.